Hi, welcome back to another Study with Me session. My name is Amy. I'm the head tutor at Pinnacle Coaching College. So what I've got for you today is a session on proving trigonometric identities. It's a topic that does get examined almost guaranteed in the upcoming preliminary exams, and I do find that a lot of students do struggle with this topic. So hopefully through the examples I go through today, it will help you sort of wrap your head around how you manipulate identities, when to consider which identity. And I'll give you also a couple of rule of thumbs to sort of take home, just pointing you in the right direction. If you've done enough of this, you will start to see a pattern around sort of the different triggers on when you do what. And if you're picking up on that, you'll find this topic is actually very, very easy to wrap your head around. So there are two sections to this. The sort of advanced math 2-unit components. So we'll look at that as well. So that's going to be relevant for all students. And then I've got the additional identities in the extension course as well. All right, so let's get straight into it. Okay, so before we get started, it's good to become familiar with what is on the reference sheet. Yeah, I know a lot of students actually rely very heavily on the reference sheet for the formulas, and that's fine. You just have to, well, first know what's in there, what's not in there, and then be able to convert what's in there into something you can use in the exam as well. Generally, I recommend actually memorizing most of these identities, especially in an exam condition. You're not going to have the luxury of time slowly flicking through the reference sheet and trying to figure out what you're supposed to use. And hopefully, if you're practicing, you shouldn't have to flick through a reference sheet anyways. All right, so let's have a look at what's in there. So you can see that it's got basically the bare minimum when it comes to the 2-unit course or identities relevant to our 2-unit students here. So you've got sec and sec and cosec and cot. So basically, these are just the reciprocal ratios. Now it's interesting that they've actually quoted this. I just noticed it. I only just looked at the reference sheets carefully today. They only have cot as a cos on A. They don't give you the tan, which is kind of interesting. So I just want to point that out. So tan, which is another one you probably use way more often than the cot version, is sine A on cos A. Okay, and cot is also 1 on tan. I just want to point that out. Yeah, because we use this version quite often as well, depending on what you're trying to achieve. So you've got the reciprocal ratios, and then you've got the last identity here, which is what we call the Pythagorean identity. Now you only have the most basic one here. There are two variations of this, which I also recommend you remember. And as I go through some examples, I'll also start rearranging this identity as well. So it's also good to become familiar with the variations of this basic identity. All right, so let's take a look at that. I'll do that in a different color. So your starting point is cos A squared plus sine A squared equals to 1. If you take this ratio and divide everything by cos square, okay, so cos divided by cos is 1. Sine on cos, so sine on cos is tan, and squared for this one. And 1 on cos, you see 1 on cos is sec square. All right, so that's another variation of the Pythagorean identity. And then same starting point, cos A squared plus sine A squared equals to 1. And this time you divide everything by sine square. All right, so cos on sine is cot. and sine on sine is 1. 1 on sine you can see is cosec. So you can see, even just off the top of my head, right, you're missing 1, 2, 3, 4 relationships already. So that's why the reference sheet is a good basic set of formulas for the desperate. That's kind of how I see it. To really do well in the maths exam, you kind of need to remember a lot of these identities. All right, so anyway, so I've shown you how to derive it. So in any case, if you don't remember it, you can look at the reference sheet and derive it. All right, so let's take a look at some typical exam questions in this area. And what I'm going to do is start with some kind of easy ones and then progress to some more difficult ones. All right, so this first one. Now, what I've also noticed is they've taken out the complementary angle identities in the reference sheet, which is a little bit curious for me. But anyways, before we attempt this question, right, let's quickly revise the complementary angle identities. So there are 3 versions, right? So cos 90 minus theta is sine theta, and vice versa. So it works the other way as well. So I'll just do it in a different color. It can also work as sine 90 minus theta is equals to cos theta. Okay, so I won't write the same thing, but that's essentially same identity but a different variation. Now, this complementary angle identity, let me actually write it. It's a complementary angle. Okay, so I'll just write like that. All right, so the other one is tan. 90 minus theta is cot. And again, it works the other way. So if this is cot and this is tan, it works just the same. And finally, second cosec, which, if you think about it, originates between the relationship between sine and cos. Because remember, second cosec is based on sine and cos. Right, and then it works the other way as well. All right, so you kind of get the point around these complementary angle identities. All right, so let's try doing this. So the first one, sine 90 minus theta is basically this bit here. Sine 90 minus theta is cos theta. 90 minus theta should be cos theta. All right, so that's cos theta on top. Cot 90 minus theta. So it's basically this one here is tan theta. All right, so that's the initial conversion. And then from here, now the first tip I'm going to give you is this. I'll also do a summary at the end just to make sure I hammer the point across. If you see a squared ratio, go look at the Pythagorean identities. So these ones. So 1, 2, 3. These are the Pythagorean identities because they are based on squares of the ratio. And most likely you're going to find your answer there. So if you look at this one in particular, right, you see how 1 plus tan squared is sec squared? That's what I'm going to use. So let's come back to here. Sec squared. All right, that's great. So now, what is sec squared? Now, usually I find that if you're not very good with manipulating fractions, write it like this. Because I do often get a lot of students confused about the fraction on fraction and end up canceling out the wrong thing or multiplying the wrong thing. So if you want to avoid mistakes, just write it. This is basically cos theta divided by sec theta squared. What does sec theta squared represent? 1 on cos theta squared. And when you divide by a fraction, it's the same as multiplying by the reciprocal. All right, so that way it's a little bit longer, but you're much less likely to make mistakes. And that's it. All right, so this expression here can be simplified into cos theta cubed. All right, so I probably didn't start with the simplest one. I thought this was simple, but maybe it's a little bit more tricky. But what you can see in this question is how I've used multiple identities, right? And I'm trying to describe my thinking process to you as I do it, because there's not much point me just showing you an answer, right? You realistically have to do this in an exam. You have to do this analysis that I'm doing in your own exam. All right, so I'm going to try to explain what's going through my head as I do it, and hopefully you pick up a few gold nuggets from there. All right, so moving on. So this is a multiple choice. This one's actually quite simple, actually. I should have started with this one. So in this one, you get just looking at the thing, right? You've got a single fraction, and then the answers are all a single ratio. So the starting point for this one, especially sort of looking at the top and bottom, it looks like I can factorize it, right? So that's the starting point. Try to factorize it first. So sine theta is a common factor. And then you can see cos theta is also a common factor. Okay, so once you factorize it, it's like, whoopee, they cancel. How good is that? So you're basically left with sine on cos. And what is sine on cos? Tan. Hey, done. Piece of cake. All right, so now you'll realize I recognize these ratios very quickly because I remember most of them off the top of my head, to be honest. So I can say, oh, sine on cos is 10. That's it, right? And you'll see a lot of that as we go through some of the questions. I kind of know what the right-hand side that we're shooting for is in a simplified form. So with that mental map, that's what I try to shoot for. So let's go on to the next one. All right, so this is one where we're gonna use a rearranged version of the Pythagorean identity. So remember, the Pythagorean identity is that cos theta squared plus sine theta squared is equals to 1. Excuse me. Now, also remember the sort of rearranged version of this. So if you make cos theta the subject, right? So cos theta squared is equal to 1 minus sine theta squared. Yeah, if you move that to the other side. So that's one version, version A. Another version is if you make sine theta squared the subject. All right, let's call that version B. So you can say version A, version B. Yeah, remember those variations because it's going to make picking up things faster. So this one, you can see why I've gone through that first, because 1 minus cos theta squared is basically version B. Yeah, so I know I can replace that with sine theta squared. All right, so next up, what is sec? Sec is 1 on cosine. Okay, so you have sine on cos, which is, that's right, tan. Tan theta squared. That's it. Very, very simple. All right. So let's take a look at this one. Now, again, I want to run you through what's going through my head. So this is another sort of second tip from me when it comes to dealing with trig identities. Generally speaking, there's just a lot more identities that converts into sine and cos. So I would say as a general rule of thumb, you try to convert your expressions in terms of sine and cos. Okay, so that's sort of the second rule of thumb. Now the third rule of thumb I'm going to talk about in this one is relevant in this one as well, is you notice the construction of this is a fraction plus another term is equals to one thing. So usually you start with the side where there's multiple terms and you try to make it one single fraction first. Usually just by making it one single fraction, you'll start to see the identity emerging. All right, so that's a little tip for me. If you have multiple things in fractions added together on one side, your first step is make it one fraction. All right, so before I even do that, this is the planning that goes into my head. I'm going to go from left-hand side to right-hand side. And if you look at right-hand side cos theta, what is cos theta? In my mind, cos theta can be two things. Either 1 on tan theta or cos theta on sine theta. All right, so in my mind, I already know, okay, that's what I'm looking for. Okay, so park that. Let's work on the left-hand side. right, so to begin with, I'm going to make this one fraction. Well, how do you make things one fraction? Common denominator. So I need to times this by sine theta on sine theta. So they're on a common denominator of sine theta. Oh, I better not jump the gun. I'll keep them separate for now. Okay, so you can see now they're both on denominator of sine theta, so you can now add the top together. And then, whoops, that's meant to be cubed. Okay, so then cos theta is a common factor, take it out. Now, at every point, I kind of cross-check, right? Like, does this path actually make sense? And if you kind of look at it, okay, I can already see I've got cos on sine, which I know that's what cot is. All right, so that's good. And that is the Pythagorean identity. So it's equal to 1. All right, so I'll just continue up here. So that's equals to cos theta times 1 on sine theta, which I know is cot theta. That's it. All right, so I think this question kind of demonstrates how important it is to know what you're shooting for, because how you manipulate it depends what you're shooting for. And there's so many identities, right? You have to pick. So just to summarize so far, right? In this question, we kind of saw if there's fractions involved, and multiple terms involved, try to make it one single fraction, yeah? And then so generally speaking, convert everything into sine and, in terms of sine and cos if it's not there already, okay? And factorize, simplify, that's pretty standard stuff. All right, so let's have a look at the next one. Okay, so now this is another classic, right? You see two fractions adding to one single term. Alarm bell should be going off saying, I need to make this one fraction, okay? So that's where we're gonna start. Now, before we do that, again, mentally map out what you're shooting for, because cosec is not a ratio we're familiar with. So it's just saying, what does cosec mean again? It means sine, right? 1 on sine. So that's 1 on sine. Okay, so keep in mind, that's what I'm looking for, okay? All right, so let's start. Okay, so you need to make it one fraction. Common denominator needs to have both elements because they're different. So you multiply the relevant ratio, top and bottom. All right, so that's looking good. So you've got 1 minus cos theta on top. Okay, so you can see now denominator is the same. You can add the numerator up. So I try not to do too many things in one step. Normally, if I was attempting this question, I'd probably do a lot. I'll skip a lot more steps, but today it's about, you understanding the process. I'm trying to slow it down a bit, all right? So the cos theta cancels out. 1 plus 1 is 2. Expand the bottom, that's difference of 2 squares. So remember, a plus b, a minus b expands into a squared minus b squared. That's all I'm doing. Okay, so when you get down to here, pause. Compare this to what you're shooting for. So it's not quite the same yet, but I also know that 1 minus cos theta squared is sine theta squared. Remember, that's the rearrangement. Yeah, 1 minus cos theta squared is sine theta squared. It's a rearrangement of the Pythagorean identity. So I'm just gonna keep squeezing it down here. So that's sine theta squared. which we know is the same thing, okay? So if you want, you can stop here and go right-hand side is that, so therefore left-hand side is the same as right-hand side, or just go 2 cosec theta square, because that's actually, you know, this is 2 cosec theta square. Right, that's it. All right, hopefully that makes sense to you. Yeah, again, I like to interact with you. If you have any questions, please feel free to leave any comments down below. Moving on. All right, so this is another exam question, so a multiple part question, which it's good in a way, yeah. They're not trying to directly ask you to show that is that, yeah, because that leap is actually a lot harder than giving you that intermediate step. So we're going to use that intermediate step to help us here. So I'm just going to save some space. All right, so the first one. Let's start with the left-hand side. Again, there's a couple of things that we've talked about already that's appearing. So you've got sec, tan. Right-hand side is all sine and cos. So first thing is change everything into sine and cos, right? Pick up all the identities that does that. Second thing, notice is something plus something equals to one thing. So there must be some sort of fraction simplification involved. All right, so let's see how this is done. So sec is 1 on cosine square. And sec is 1 on cosine, this one. And tan is sine on cos. All right, step 1, done. Now, if I simplify this, notice they have the same denominator. You don't need to simplify, just add the numerator together. And that's it. Okay, so I'll just say equals the right-hand side. All right, so the second one. So now you kind of got a middle landing, and then you try to build a bridge to this side, right? So let's start with left-hand side. So I'm just going to copy the question first. And then we're going to use part 1, right? We've already shown that. You don't need to show that again. All right, so I'll just make a note. All right, so now you're just trying to build a bridge from there to there. Now, the main thing I can see, there's not much you can do about the 1 plus sine x, because there's really no identities that let you do anything with that. But cos x squared, any of the squared ratios have a lot of identities, particularly the Pythagorean identity. So let's go back a few steps. So remember the Pythagorean identity, so cos x squared is actually 1 minus sine squared. That's very, very useful, and you'll see why. Okay, so let's do that first. Okay, so this is actually a difference of 2 squares. So basically you have 1 minus a squared essentially, right? So that's 1 minus a, 1 plus a, difference of 2 squares factorization. So that's what we're going to do. And then they cancel out, which is perfect because that's what you're after. I'm going to try to squish it in here. That's it. All right, so that's pretty much as hard as some of the 2-unit level questions are really going to get. So just to summarize, right? So what are the sort of rules of thumbs, I call it, yeah? Rules of thumb. I might type this so it's just easier for you to read. All right, I don't know if I can make it bigger. Oh, yeah, it's pretty big. Okay. All right, so the first rule of thumb, let's think about this, right? Try to convert your ratios in terms of sines and cosines, unless it's very obvious that you want everything in terms of tan, and you will see some of that in some of the questions later. All right, so I'll just write that up first. So convert ratios in terms of sine x and cosine x where relevant. Okay, it's not 100% gonna be relevant all the time, but it's most of the time true, right? All right, so second one. Let's do that. All right, so that's rule number 1. Rule number 2. If there are multiple terms on one side, which ends up being one single term on the right side, most likely there is some sort of fractions, and you have to make things in one fraction and simplify. Okay, so I'll just say on left-hand side generically. All right, so that's your second one. Now the third one is if you see ratios that are squares, most likely there's some sort of Pythagorean identity being used, so that's where you should look. All right, so I guess more generally, yeah, focus on factorizing, cancelling out. Those are sort of like the smaller maneuvers you can do. Yeah, I'm just trying to think what else. Let's just gonna use this. Yeah, I'm just gonna go back and see what else, what other tips I can give you. Yeah, I think I've given you most of the important techniques to look at. Oh, this other one is good. Okay, I think this one, you're gonna appreciate this one. All right, so finally, I'm gonna delete this thing. It's in my way. Always check your destination, meaning know what you're proving on the right hand side, right? Because there's a lot of identities, especially once I start looking at the extension 1 stuff, you'll find that there are so many identities. When do you use what? That's why what you're proving, it's important, right? And you saw in some of the question, I kind of undid the right hand side a little bit just so that you know what you're shooting for, right? Always check your destination or what you are shooting for. Okay, so I think these are 5 tips for you, and I think that should be an immense help when it comes to breaking down identities. The rest is just practice. All right, so if you practice, I'm pretty sure you'll get there eventually. So this is it for part 1 of proving trig identities. This part focused on the identities you need for the 2-unit exam typically. The extension 1 identities will be in the second part 2 of this series. I've left the link down below if you're an extension 1 student and would like to check that out. Otherwise, if you have any questions, comments, please leave a comment down below, or you can contact us through our website, Facebook, or email. All right, so that's it. Hopefully, it all makes sense. And good luck with your studies.